For oxygen measurement, we have three techniques that allow us to do that. The first one is the polarographic technique, which has a construction that looks like this, where we have a platinum electrode, and we have an electrolyte, and we have a silver electrode. Basically, we have a Teflon membrane right there, and this is a site where we sense the oxygen. Basically, the idea is that when the oxygen molecules come through this Teflon membrane through diffusion, by diffusion, they will react with this electrolyte and basically cause a current to flow between the silver and the platinum electrodes. And this current can be measured, and basically it can be used to get the concentration of the oxygen. Galvanic cell or fuel cell sensor has a very similar idea to the polarographic method, polarographic technique, where you have a sensing membrane as well, and you have an electrolyte, and you have an anode. And basically the same thing also happens here, where you have a current that flows between the cathode and the anode based on the concentration of oxygen flowing through this membrane. The problem of these two techniques is that both rely on diffusion of oxygen through the membrane and through the electrolytes. And basically, this causes both of them to have a very slow response time between 20 and 30 seconds. So in order to measure an oxygen reading, we have to wait for almost half a minute to get one. Okay, and this is not a very good response time for safe measurement of oxygen. The third technique is the paramagnetic technique, which relies on the fact that the oxygen has a paramagnetic characteristics. Paramagnetic characteristics mean that it's affected by a magnetic field. So whenever we apply a magnetic field, the oxygen follows the magnetic field. Basically, in the regular without magnetic field, in the steady state, oxygen can be arranged in any random orientation. And basically, whenever we turn on the magnet, the oxygen will have to follow the magnet. We have to align with the magnet. So basically, it will cause motion in the inside of the part where the oxygen is present. And so we can actually use that because the motion of the oxygen with the magnetic field will cause a higher pressure in the side where the oxygen is present, and so we can actually measure that with respect to another reference. We measure the difference between the pressure in these two compartments with the use of switched magnetic field, and basically we can get a reading with a very fast response time for the oxygen concentration. So basically, it can measure inspired and expired oxygen concentration on a breath-by-breath basis. So basically, you can get an updated value for oxygen each breath, which is really very good. So basically, this is why this is the most widely used oxygen sensor in the market today.